when we use thermodynamics to study an engineering device, usually we have to treat this device as a so-called system, in which working substances undergo a series of processes involving property changes, so that the system, which is the engineering device, can exchange energy with its surroundings by means of heat transfer, work transfer, and mass transfer. This, in fact, is a very typical perspective of thermodynamics when we study an engineering device. In this description, you can see we have lots of new concepts like system, working substances, processes, and so on. And I will explain such concepts one by one. First, system. A system is something we isolate from the rest of the universe and study with laws of thermodynamics. So system, in fact, can be anything. Anything we focus on and we study with thermodynamics is a system. So once we identify a system, then of course everything outside of the system is its environment or surroundings. The interface between the system and its surroundings is called the boundary of the system. A system can have interactions with its surroundings. In fact, we only have three possible interactions, which are heat transfer, work transfer, and mass transfer. In thermodynamics, we study two types of systems, which are closed systems and open systems. A closed system is also called a control mass. It is a fixed quantity of mass. So if you find yourself studying some fixed quantity of material, then you are studying a closed system or a control mass. For a closed system, its boundary may be fixed or movable. For example, here we have some air enclosed in a perfect piston cylinder. It's perfect because the piston in fact can move freely along the inner surface of the piston without any friction, and at the same time the piston fits the inner surface of the cylinder perfectly, so there is no any leaking between the gap through the gap between the piston and the cylinder, because there is no such gaps. So it's a perfect ideal piston cylinder. If we are studying the behavior of air enclosed inside such a piston cylinder, in fact we are studying a closed system, because what we are studying is a fixed quantity of mass. So for example, here if I use a candle to heat up this air inside the piston cylinder, then obviously this air is going to expand because of its increase in temperature. So as you can see, in such a case, the system, which is the air enclosed in this piston cylinder, in fact has a movable boundary. Okay, its boundary is not fixed. Instead, the boundary is changing with time in this process. So for a closed system, in fact, its boundary can be fixed, can be movable. And for a closed system, it can exchange heat and work with its surroundings. And again, let's use this air enclosed in this piston cylinder as an example. In such a process, when the air is being heated up and expands, you can see there is heat transfer between the system and its surroundings. In fact, heat continuously goes into the system from the surroundings. And at the same time, because the system expands and pushes the piston upward, so the system in fact does work on its surroundings. So there is also work transfer between the system and its surroundings. So for a closed system, in fact, it can have exchanges of heat and work with its surroundings, but it cannot have any mass exchange with its surroundings, because according to the definition of a closed system, it is a fixed quantity of mass. So definitely it cannot have any mass exchange with its surroundings, otherwise it's no longer a fixed quantity of mass. The second type of system is an open system. An open system is also called a control volume, which is an identifiable volume or space with possible mass flowing into and or out of this space. One example is shown here. Here we have a water pipe and the water flowing through this pipe. At the same time, the pipe is being heated up, so the water temperature increases as it flows through the pipe. Now if we focus on this pipe, then it's it's an open system, because this pipe is an identifiable volume or space. And obviously here, for this open system, we have mass transfer across its boundary, because mass continuously flows into this space and flowing out of this space. In fact, for such an open system, all three interactions between the system and its surroundings are possible. Recall that there are three possible interactions between a system and its surroundings, which are heat transfer, work transfer, and mass transfer. Obviously, for such an open system, the mass transfer definitely is possible, and heat transfer again is possible, and in fact work transfer is also possible. As we will learn later on, when mass flows into the system or out of the system, in fact some work transfer also happens at the inlet and at the outlet. Such work transfers are so-called flow works. So work transfers are also possible for an open system. So unlike the closed system, an open system in fact can have all three interactions with its surroundings. On the other hand, for a closed system, it can only have heat transfer and work transfer with its surroundings, but it cannot have mass transfer. Now let's see some questions. This device is the so-called fire syringe. It's just a piston cylinder device. Some air is enclosed in this piston cylinder, and if we press down the piston really quickly and the air is compressed very quickly, then its temperature is going to increase a lot. Its temperature can become so high that the cotton you put inside such a piston cylinder can be ignited. So that's why it is called a fire syringe. So now the first question is, if I treat the air enclosed in this piston cylinder as a system, is it a closed system or open system? Well, the answer is a closed system, because the air enclosed in such a piston cylinder obviously is a fixed amount of material. So it's a closed system. So how about this jet engine? This jet engine installed on an airplane, is it a closed system or an open system? Well, now this jet engine in fact is an open system because it has mass transfer across its boundaries, right? Air continuously flows into this engine, and combustion products continuously flows out of this engine. So since there exists mass transfer across its boundary, it must be an open system. The third question, how about your body? Is your body a closed system or an open system? Well, obviously, your body is an open system because you have to breathe, you have to eat, you have bile breaks. So your body, in fact, is an open system. See this question. When you inflate a balloon, what are the interactions between the balloon as a system and its surroundings? To answer this question, let's first see if the balloon a closed system or open system. See, here we have a balloon and we are inflating it. Then of course, as time goes on, this balloon becomes big. Now if I treat this balloon as my system, so this is my system, is it a closed system or open system? Okay, obviously it's an open system, right? Because if you treat the balloon as your system, then there is mass transfer across the boundary of your system. Air is continuously pumped into your system. So there exists mass transfer across the boundary of your system. It is an open system. For such an open system, you can see obviously we have mass transfer between the system and its surroundings. So here is my system, and everything outside of the system is its surroundings. So firstly, there exists mass transfer. Do we have work transfer? Well, the answer is yes. Okay. The reason is because when our system, that is the balloon, is being inflated, it will expand, right? So as the balloon expands, it will push the ambient air, the surrounding air, for a distance. So the balloon exerts a force on the ambient atmosphere and also pushes the atmosphere away from it for a distance. So this is work transfer. Do we have heat transfer? Well, most likely yes. Okay, if you inflate a balloon by breathing air into it, then the air temperature you breathe into the balloon typically is different from the temperature of the ambient. So there may be some heat transfer because of this temperature difference. So as you can see, if we treat the balloon as our system, it is an open system, and all three transfers or three interactions are possible. Okay, mass transfer, heat transfer, and work transfer. So how about we use the balloon skin with all the air eventually within it as our system? So here we have a balloon, and we breathe air into this balloon, so eventually this balloon becomes big. Now if I use this balloon skin and all the air eventually inside this balloon as my system. Okay, so this is my system. So now the first question is this system a closed system or open system? The answer is now it is a closed system, because now what we are studying in fact is a fixed quantity of material. Okay, the system always consists of the balloon skin, which is some fixed quantity of material, and this chunk of air. Okay, this amount of air which stays in the balloon at the final state of this process. So it's a fixed amount of material. Okay, so now we are considering a closed system. Then if I ask you, where is this system at the initial state? Okay, at the beginning of the process when you inflate the balloon, then obviously the balloon skin is here, right? Then where is this chunk of air? Okay, the answer is very simple. This chunk of air most likely is in your lungs. Okay, so for such a closed system, in fact, what happens is that this chunk of air flows into this balloon, right? Then occupies the space inside this balloon skin. So although this closed system, you can see its boundary is changing and part of this system goes into the other part of the system, but it's still a closed system because there's no mass transfer between this system and the rest of the universe. Okay. So firstly, there is no mass transfer. Okay, because it is now a closed system. Do we have work transfer? The answer is yes. Okay. Obviously, again, this balloon is expanding in this process, so it's going to push the ambient air away from it. That is, it gives a force on the ambient air, and in fact, this force is applied to the ambient air for a distance. So this is work transfer. Okay. In fact, when you breathe this chunk of air into this balloon, your lungs, in fact, have to do some work on this chunk of air. Okay, so that your lungs pushes this chunk of air for a distance into this balloon. So that is again work transfer, right? And because the air you breathe into this balloon typically has different temperature from the ambient temperature, so there may be heat transfer. So if you use the balloon skin with all the air eventually within the balloon as a system, it's a closed system. It can have heat transfer, it can have work transfer with its surroundings, but it cannot have mass transfer because it's a closed system. Sometimes we consider some special systems. Okay. For example, adiabatic system. An adiabatic system is a system that has no heat transfer with its surroundings. For example, a well-designed cooler can be approximated as an adiabatic system because it's so well designed and so well insulated, so it has no heat transfer with its surroundings. Another special system is an isolated system. An isolated system is a system that has no interactions with its surroundings at all. It has no mass transfer, it has no heat transfer, it has no work transfer with its surroundings. Then such a system is called an isolated system. Okay, it's totally isolated from the rest of the universe. It has no interactions with the rest of the universe whatsoever. Now let's say one simple example. Suppose here we have two blocks. One block is hot, is red block, and another block is cold, is blue block. And when we put these blocks together, obviously the hot block is going to, give heat to the cold block, right? So heat transfers from the hot block to the cold block. Now let's assume that heat only goes from one block to the other block, and there is no any heat transfer between these two blocks and the rest of the universe. Okay, there's no other there's no heat transfer between these two blocks and the other stuff. Okay, the only heat transfer is between these two blocks. Now the question is, can you identify an adiabatic system in this figure? See, in this figure or this figure. Do we have an adiabatic system? Okay, the answer is yes. Okay, if we use these two blocks together as a system, okay, this is my system, then it is an adiabatic system because there is no any heat transfer between these two blocks and the rest of the universe, right? Although there exists heat transfer between these two blocks, but since I use both blocks as my system, so such heat transfer is, inside my system. It is not between my system and its surroundings. So in such a case, the system in fact is an adiabatic system. Okay, so this finishes our second video. Hope you enjoy it. And thank you.